Hi, today I am going to discuss the reactions of amines. Okay, then first one, reaction with acids or basic character of amine. Okay, being basic in nature, all types of amines react with HCl, HNO3, H2SO4 etc. to form soluble salt. Okay, consider an example. CH3NH2 plus HCl, same monobasic acid, to get CH3NH3Cl minus. So alkyl ammonium chloride. This is the primary amine. We will get alkyl ammonium chloride. Okay, then likewise aniline can also react with HCl to form ammonium chloride. C6H5NH2 plus HCl gives C6H5NH3 plus Cl minus. This is known as aniline chloride. Okay, then likewise H2SO4 also react with the amines to get a corresponding salt. Okay, for example, 2CH3 twice NH plus H2SO4 to get CH3 twice NH, CH3 twice NH2 plus twice SO4 2 minus, that is dimethyl ammonium sulfate. Ammonium sulfate. Likewise, HNO3 also react with amines. For example, tertiary amine, CH3 thrice N plus HNO3 will get CH3 thrice NH plus NO3 minus. This is known as trialkyl ammonium nitrate. This is the basic character of amine. So, all type of amines react with HCl, HNO3, H2SO4 etc. to form its soluble salt. Okay. Then next reaction is alkylation. Then primary, secondary and tertiary amines react with the alkyl halides to form secondary amine, tertiary amine and quaternary ammonium salt respectively. The process of introducing an alkyl groups into molecule is called alkylation. Okay, the process of continued alkylation of amine using excess of alkyl halides until the quaternary ammonium salt is obtained is called exhaustive alkylation. Okay, the example RNH2 react with RX. RNH2 react with RX minus HX. We will get R2NH. So secondary amine. This primary amine. This again react with another molecule of RX. We will get R3N. R3N means tertiary amine. Again react with an RX. We will get R4N X minus X minus. Okay, we will get a tetra-alkyl ammonium halide. Tetra-alkyl ammonium halide. Consider a specific example. The process of continued alkylation, methylation of an amine using excess of methyl halides until the quaternary ammonium salt is obtained is called exhaustive methylation. Okay, consider instead of R we are substituting with CH3 or methyl amine. CH3 NH2 react with the CH3Cl minus HCl, we will get CH3 twice NH. Again react with the dimethyl amine. Again react with the CH3Cl minus HCl, we will get CH3 thrice N. That means trimethyl amine. Again react with the CH3Cl, we will get CH3 4 times N plus Cl minus. That is tetramethyl ammonium chloride or quaternary ammonium salt. Okay, quaternary amine salt. This is the alkylation reaction. Next, we are going to discuss acylation. Acylation. What is acylation? Acylation, the reaction with the acid chlorides and acid anhydrates to forms amide. These types of reaction is known as acylation. Okay. Acylation refers to the process of replacement of a hydrogen atom of the amino group by the acyl RCO group. Primary and secondary amine undergo acylation when treated with the acid chloride or anhydrates in the process of base to yield N-substituted amines. This reaction is known as acylation. Okay, now the point when amines react with the acid chlorides or acid anhydrate to form a substituted amines. Such reaction is known as acylation. Consider an example: RCOCl is an acid chloride react with the RNH2 and H and Cl condensed and to form minus HCl, OH minus HCl, we will get RCO NHR. Okay, we will get a N substituted amide. N substituted amide. This reaction is known as acylation. Consider a specific example. When acetyl chloride CH3COCl react with the ethylamine C2H5NH2 in presence of base H minus, you will get CH3CONH C2H5 NHC2H5. This is the N-ethyl acetamide. N-ethyl acetamide. Then one more example with the acetic anhydride CH3CO twice of acetic anhydride react with a dimethyl amine CH3 twice NH. We will get after acylation, the removal of CH3COH. COH. Yes, CH3COH. We will get CH3CO, CON, CH3 twice, and CH3 twice. NN dimethyl acetamide. NN dimethyl acetamide. This is the acetylation reaction. Okay. Then the tertiary amines do not undergo acylation because they do not possess replaceable hydrogen atoms. Okay. Then tertiary amines do not react with the tertiary amine CH3 thrice N do not react with the acid chloride or acid anhydride because tertiary amines do not contain a replaceable hydrogen. So primary and secondary amines easily react with acid chloride or acid anhydride to form substituted acetamide. But tertiary amines do not undergo acylation because they do not possess irreplaceable hydrogen atoms on nitrogen. Likewise, acetyl chlorides react with the aniline to get corresponding acetamide or N-phenyl acetamide. Okay. This reaction is known as acylation. Then next, we are going to discuss the benzylation. Benzylation or reaction with benzyl chloride in presence of a base. Reaction with the benzyl chloride in presence of a base or Schotten-Bowman reaction. Schotten-Bowman reaction. Then benzylation refers to the process of replacement of a hydrogen atom of amino group by benzoyl group. Primary and secondary amine undergo benzylation with when treated with the benzoyl chloride in presence of a base like pyridine or NaOH to yield N-substituted amines. Okay. We'll repeat. The benzylation refers to the process of replacement of a hydrogen atom of amino group by the benzoyl C6H5CO group. Primary and secondary amines undergo benzylation when treated with the benzoyl chloride in the presence of a base like pyridine or NaOH to yield N-substituted amide. This reaction is known as benzylation. Okay, then benzoyl chloride C6H5COCl react with the C2H5NH. Benzoyl chloride react with the amine, the ethyl amines to get amide in presence of a base. We will get C6H5CO CONH C2H5. This is known as N-ethyl benzamide. N-ethyl benzamide. This reaction is known as benzylation reactions. Likewise, aniline also react with C6H5COCl C6H5NH2 presence of OH minus. You will get C6H5CONH C6H5. Okay, this is benzanilide. This reaction is known as benzylation reactions. When benzylation of a compound containing active hydrogen such as alcohol, phenol, amines, etc. using benzyl chloride in the presence of a base called Schotten-Bowman reaction. Okay, that is benzylation of a compound containing active hydrogen such as alcohol, phenol, amines, etc. using benzyl chloride in the presence of a base called Schotten-Bowman reaction. Okay. Next, we are going to discuss the carbylamine reaction. Carbylamine reaction. Carbylamine reaction. Fifth one, carbylamine reactions. Very, very important reaction, carbylamine reaction. We have to study the carbylamine reaction and its mechanism, stereochemistry, etc., etc. So this is an important reaction. Okay. Carbylamine reaction or Hoffman carbylamine reaction or isocyanide reaction. Hoffman carbylamine reaction or isocyanide reactions. Okay. Aliphatic as well as aromatic primary amine when treated with chloroform and an alcoholic solution of KOH yield the corresponding carbylamines, also called isocyanide, which have a characteristic foul or unpleasant smell. This reaction is known as carbylamine reactions. Okay, one more. Aliphatic as well as aromatic amines when bound with chloroform and alcoholic solution of KOH are NH2 plus CHCl3 chloroform or NH2 primary amine and chloroform in presence of a base, presence of a alcoholic solution of base KOH, alcoholic KOH, we will get RNC or alkyl carbylamine or alkyl isocyanide 3KCl plus 3KCl plus 3H2 or alkyl cyanide, alkyl isocyanide or alkyl isocyanide or alkyl carbylamine, alkyl carbylamines. This reaction is known as carbylamine reaction or Hoffman carbylamine reaction. This is a specific example: C2H5NH2 plus CHCl3 plus 3KOH yield C2H5NC plus 3KCl plus 3H2O. This is ethyl carbylamine. Ethyl carbylamines. Okay, this reaction is known as carbylamine reaction. Okay. Next reaction is Hoffman elimination or conversion of amine to alkene. Hoffman elimination or conversion of amine to alkene. Conversion of amine to alkene. Hoffman elimination or conversion of amine to alkenes. Okay. The process of exhaustive alkylation of amine using excess of alkyl halides yields quaternary ammonium halides or tetraalkyl ammonium halides. The process of exhaustive alkylation of amine using excess of an alkyl halides yield the quaternary ammonium halides or tetraalkyl ammonium halides. Okay, if take excess of alkyl halides or amines react with the excess of alkyl halides, we will get primary amines, tertiary amines, and final quaternary ammonium halides. If we will take excess of alkyl halides, okay, then RNH2 react with the excess of alkyl halides, RX we will get R dash X, right? R NH R dash react with the R dash X, you will get R N R twice dash, you get RX dash X R secondary amine, tertiary amines, and then we will get quaternary amine R dash 4 times 6 minus quaternary ammonium salt. So not salt is equal to 3. Okay, tetra alkyl ammonium halides. Okay, first we will get primary amine, then minus HX secondary amine minus HX tertiary amine, we will get quaternary ammonium salt. Okay, when tetraalkyl ammonium halide is hydrolyzed with moist silver oxide, the corresponding tetraalkyl ammonium hydroxide is obtained, or the tetraalkyl ammonium halides, tetraalkyl ammonium halides boiled with moist silver oxide, boiled with silver oxide, silver hydroxide, not silver oxide, silver hydroxide. Silver oxide react with moist with silver hydroxide to get the corresponding hydroxide. Is R N R price. AgX. Okay. Suppose the alkyl groups, the R contain the alkyl groups, this alkyl group. Okay. This alkyl groups. Now suppose the alkyl groups are contain 2 or more carbon atoms and thus contain beta hydrogen. Suppose the alkyl groups, group means the alkyl group initially present at the amine part. Okay. Suppose the alkyl groups are contain 2 more C atoms and thus contain beta hydrogen. In such cases, when the tetraalkyl ammonium hydroxide is heated strongly, it decomposes to yield tertiary amine and alkene. Okay, then the R group contain more than 2 carbon atoms is all heated to get a amine, to get a alkene and amine, tertiary amines. Okay, in such cases when tetraalkyl ammonium hydroxide, that is tetraalkyl ammonium hydroxide means this tetraalkyl ammonium hydroxide is heated strongly, it decomposes to yield tertiary amine and an alkene. This reaction is known as Hofmann elimination. The nature of alkene formed depend upon the structure of alkyl groups R. Some examples are given below. Consider the R groups. Consider the R groups is a ethyl groups. We will get ethyl CH3 CH2 CH2 CH3 CH2 N, and consider the R dash is a CH3 group. CH3 twice. Which minus on heated to get plus H2. That means, suppose this is the R groups and this is the R dash groups. So this alkanes converted into alkene. Alkane converted into alkenes. This step is known as Hofmann elimination. Hofmann elimination. Suppose the R groups. Suppose this R group is a propyl group. Is CH3, CH2, CH2, N, and this R dash groups again CH3, OH minus. We will get a propene, CH3, CH2 plus S. Okay, this step is known as Hofmann elimination. Okay, next we are going to discuss the Hofmann elimination mechanism, stereochemistry, etc. Okay, for Hofmann elimination of an N-butylamines or butane-1-amine, which finally yields but-1-ene and trimethylamine, is given below. Suppose when butylamines react with the consider we initially taken N-butylamine. N-butylamine means CH3, CH2, 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 NH2. N-butylamine is taken as initially react with the excess of methyl iodide, CH3I, methyl iodide. After exhaustive methylation, we will get CH3, CH2, 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 N, CH3, twice. Okay, that is N-butyl trimethyl ammonium iodide. N-butyl methyl ammonium iodide. This on treated with the AgOH. This on treated with the moist silver oxide or AgOH. We will get CH3, CH2, 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 the corresponding hydroxide. N, CH3, twice. Okay, corresponding hydroxide. N-butyl trimethyl ammonium hydroxide. The last step, this on heat. What will we get? The normal butyl parts undergo elimination to get but-1-ene. This part we will get the trimethyl amine. Okay, this on heat we will get CH3, CH2, CH, double bond CH2. That is but-1-ene. But-1-ene and trimethyl amine. CH3 twice N plus H2. So, summation of this reaction is known as when when primary amines converted into amine is converted into alkenes. Okay, amine is converted into alkenes. That is why when amines undergo exhaustive methylation, we will get a corresponding tetra-alkyl halides. Tetra-alkyl halides on heated to get alkenes. This reaction is known as Hofmann elimination reaction or Hofmann reaction. Next, we are going to discuss the mechanism of Hofmann elimination. Next, we are going to discuss the mechanism of Hofmann elimination. Then Hoffman elimination is a nucleophilic beta elimination reaction that proceeds by E2 mechanism. Okay, Hoffman elimination is a nucleophilic beta elimination. Nucleophilic beta elimination, and also it's proceed by E2 mechanism. It proceeds by E2 mechanism. That is concerted E2 reaction using amines as the living group. Concerted E2 mechanism as amine as a living group can be simply represented by this N(R3). Okay, then base abstract a proton. Base consider the base promoted Hoffman elimination that occurs when here a base abstract a proton from alkane part and the electron shifted to here. We will get a alkene. See, and this NR3 products eliminated as a living group due to heat. We will get plus NR. Okay, this is the nucleophilic beta elimination or E2 mechanism. Okay, an example is N-butyl trimethyl ammonium. N-butyl CH3 CH2 N CH3 rice which minus on heat we will get a but1e CH3 CH2 CH double bond CH2 and CH3 rice butyl amine. Okay. The E2 mechanism for the reaction involves a concerted pathway that comprises the following occurrence. The base OH minus pull a hydrogen away from the beta carbon atom. The base that pull a hydrogen away from the beta carbon atom. This is the alpha carbon atom and this is the beta carbon atom. Okay, the base OH minus pull a hydrogen away from the beta carbon atom. A new pi bond formed between beta and alpha carbon. A new pi bond formed between alpha and beta carbon atom. A new pi bond formed between alpha and beta carbon atom. The living trimethyl amino groups is detached with bond pair as NCH3 thrice. Okay, the living trimethyl amino group is detached with the lone pair as NCH3 thrice. From this reaction we can simply represent here we can simply represent from this reaction. Consider CH3 CH2 C H C N CH3 rice CH H CH2. Okay. Okay. When this is alpha carbon, this is beta carbon. First, a OH minus pull away proton from beta carbon. Okay, or the base abstract a protons, and the electron pair shifted here to form a new pi bond, and the NCH3 group leave from here to get CH3, CH2, CH, CH2, and the NCH3 leaving with a electron pair N CH3 tracks. Okay. Then next we are going to discuss the stereo selectivity of Hofmann elimination. Stereo selectivity of Hofmann elimination. Stereo selectivity of Hofmann elimination. Okay, Hofmann elimination are stereo selective for anti-elimination. Okay, Hofmann elimination are stereo selective for anti-elimination, meaning the H and the leaving group must be anti to each other. That is, the H and the leaving group must be anti to each other. Consider the E2 mechanism. Consider the E2 mechanism depicted here. C. Okay, this is the plane of paper. This is the plane of paper. Then OH minus will abstract a proton, leaving the lone pair here, and the NCH3 leaving with its electron pair. Heat is E2. Okay, then the H and NCH3 same place but in anti position. Okay, same plane but in anti position, and the removal of H and the abstraction of protons and the removal of NCH3 in a single step. Okay, removal of H and abstraction of proton and removal of NCH3 in a single step. That's why this step is a concerted elimination, or E2. What is the reason behind the E2? E2 means elimination in bimolecular reaction. Bimolecular means the slowest step contains two molecules. The slowest step participate two molecules, that is a base and this reagent. Okay, this is the why what the anti means the H proton and NCH3 in same plane but in anti position. We will get C CH3 H plus NCH3. Okay, but 1 prop 1e is this CH3 CH2 is CH3 CH2. If it is but 1e, the later one is prop 1e. Okay, this is but 1e. Okay, then next, this is the anti-stereo selectivity of Hofmann elimination. Anti-stereo selectivity of Hofmann elimination. Then next we will discuss the regioselectivity in Hofmann elimination or Hofmann rule. Regioselectivity. Next, we are going to discuss the regioselectivity. Regioselectivity. We already know the two types of elimination reaction, that is two types of product of elimination reaction, that is Zaitsev product and Hofmann product. Or the elimination can also express Zaitsev rules or Hofmann rule. Here the E2 reactions or dihydrohalogenation of alkyl halides generally proceed to forms the more substituted alkane in each cases following Zaitsev rules. Okay, normally the elimination reactions get more substituted product. Okay, here the result is seen to be different for the thermal decomposition of quaternary ammonium hydroxide. But here in the case we will get less substituted product, that is Hofmann product. Okay. The result is seen to be different for the thermal decomposition of quaternary ammonium hydroxide or Hofmann elimination. That is capable of yielding two or more isomeric alkene. Here, unlike the predicted by Zaitsev rule, elimination occurs preferentially to form less substituted